The Water Quality Management Committee, December 17th meeting will come to order. First item on the agenda is the Acapesket Phase 2 draft report presentation by Jim Begley.
Okay.
For the benefit of our nationwide TV audience, Jim has been working for the town doing groundwater assessments in areas where PRBs permeable reactive barriers might be appropriate. And he's done one set of them in the past, and now we're into phase 2. And Karan.
Thank you, Eric. I just wanted to add in too, I was going to introduce Jim, but you did a fine job. I just wanted to remind everyone too that this work was fully funded with a $50,000 grant from the Cape Cod Water Protection Collaborative. So I would like to introduce Jim, and he will present the findings of the draft technical report.
Okay, terrific. Yes, let's find you a microphone.
So Jim's going to talk up at the podium.
Okay.
And he's got the clicker, so he can.
Perfect.
And maybe we should, Ron, could you get the light?
Yeah, I get the lights. I'll do the lights.
Now, do we need the microphone for the recording?
Yes.
Yes.
Okay.
And
Yes.
for the TV
Yeah.
audience.
Yeah.
I think that's good.
Okay.
Well, thank you. I appreciate the committee having me do this work and having me here to present it. And I want to thank Jessica and GHD for their assistance and the Falmouth DPW as well. This project, the Falmouth Acapesket Peninsula Groundwater Investigation, is a project that is in the second stage, as Eric had mentioned. We started in 2014, in the fall of 2014, with this investigation. And I wanted to just kind of give you a little bit of context first. We're focused on embayment restoration, and there are a number of different ways to go about embayment restoration. We're looking at the problem of nitrogen loading to the estuaries causing eutrophication. You can use source management, which are things like sewer infrastructure or eco-toilets. You can use surface water nitrogen mitigation, such as shellfish aquaculture and oyster reefs, or inlet widening, which is another project I know is ongoing. Or you can use groundwater nitrate remediation, which one form of is a permeable reactive barrier. And in fact, the best approach, as you all know, is to come up with a combination of these things, because no one solution really will address the problem in its entirety. So, for groundwater nitrate remediation, we need to understand what the condition is out in the groundwater. So we've done an investigation in one area, the Acapesket Peninsula, to start to collect some information. So obviously the objective is to get the data so that we can consider nitrate treatment. We have to know how much there is, where it is, what the groundwater flow system is like. We have to understand the hydrogeology of the groundwater system. And we have to consider where is the saltwater interface under the freshwater, because out in the peninsula, that's the situation that we have. So there's only a certain vertical thickness that we might need to treat. That's the freshwater lens. And we need to quantify the distribution of nitrogen in the groundwater in order to determine whether it can be treated. And we need to understand both the horizontal distribution and the vertical distribution as well. So to give you a quick conceptual description of the problem, we have sources of nitrogen, nitrate that gets to groundwater from septic systems. There are other sources of nitrogen and nitrate in groundwater and in the estuaries, but this is one of the major sources. That nitrate comes from the septic system, it gets down into the groundwater, and then migrates with the groundwater. And conceptually, again, you can see we may have a whole bunch of little plumes that are migrating to the surface water from those septic systems. Groundwater doesn't tend to mix really well. It'll flow in a path along the groundwater gradient. Basically, groundwater flows downhill. So it's moving through the sand and gravel aquifer that's beneath the ground. There's been some work by the USGS to try to understand how that sand and gravel aquifer flows. to the south coast of Falmouth and into these estuaries. Here you can see the Acapesket Peninsula in the center, and groundwater, see if this pointer works, groundwater contours. These are elevation contours of water above the water table, above sea level, at the water table where the water sits in a well. And the water is flowing downhill along those contours, so we can identify direction of groundwater flow based on this groundwater map. Groundwater flow is perpendicular to those contours, so you can see the arrows. And this is a very important consideration when we're doing our work, to figure out what is this direction of groundwater flow in the area of interest, and how fast is it flowing. If you look up in the northern part of this picture, you can see the contours are much tighter together in this modeled depiction of the groundwater table. And generally where you have those contours tighter together, groundwater is flowing faster. The Acapesket study area, again located on the peninsula between Green Pond and Great Pond, and we had two areas that we focused on. One, Acapesket South, we called it. This is the area that was first investigated in 2014. We went out to this area and put in monitoring wells, collected data at that point, and there was a preliminary report to the committee last year. We've gone out this year and done work in an additional area located to the north, up near Route 28, East Falmouth Highway, the Acapesket North area. So this is an area where, based on information that we had, the theory is this is going to be a location where there's faster groundwater flow, and based on some previous information, there may be higher nitrate concentrations than we observed in the southern area in our first investigation. We used a direct push rig, a drill rig, for the most of this work. It's a very useful tool for this kind of work, and you may have seen it, some of you out in the field, putting in these monitoring wells. It can access, areas in the woods, so it's good for that. There's another type of setup of this on a truck that's very useful for along the edge of the road. And with this, we can push wells down into the ground, build wells in soil borings that we construct. And we can also collect soil samples. The aquifer material is important to understand so that we can get a feel for the permeability, or how easy the water is going to flow through that material. We also could see possibly if there were layers that have much lower permeability, that might be a point that is impermeable to further flow deeper into the aquifer in that area. We also can collect information by looking at these soil cores, such as the nature of the material. Sometimes there's a lot of iron in the soil in Cape Cod, and you can see not a red band of iron stained material there. It's iron coating the sand grains, basically. And that's something that we need to consider when we look at groundwater remediation, because it can have an effect on the process. So out in the field, we use that geoprobe drill rig to put in monitoring wells. We put in single water table monitoring wells in some locations, and what you're looking at here is the land surface on the top. This is the well that's been installed in a soil boring. Here's that water table that we could see in the contour map that we looked at earlier. So that's the level of water in the well, and then you have a screen open to the aquifer down in the well. On this side, you can see multiple screens. These are set up in a cluster, so they're very close together, but they're screening different elevations in the aquifer so that we can see the layering of groundwater quality, basically, or a profile of groundwater quality in that area. We also had some very unique assistance from the U.S. Geological Survey. They worked with us to put in a multi-level sampler that had 14 sampling ports in an area at the Acapesket North area. And That well gave us great information on the profile of groundwater quality, because we could see every 4 feet what we had. With the other wells, the multi-level wells, we're looking at 10-foot screens spaced as we go down into the aquifer. So we're getting more of a homogeneous view, if you will, of that portion of the aquifer, because we collect a sample from the full 10 feet, as opposed to the narrow width of this screen. And this is actually the screen point, or the opening, right here. So when this is installed in the well, they can sample these tubes that are inside this casing. And there's a piece of nylon over the outside of it to keep sand from coming up into the tube. And they're constructed in the same type of holes that we put in for the 2-inch monitoring wells that we installed. You can see a picture here of the 2-inch wells in a cluster. This is one of the locations on the 0 Shorewood Drive property, which was the focus of this Acapesket North area. We have 6 screens at this location. Each one of those concrete spots that you see there is a different well. Each of them screened at different elevations down into the aquifer. And we're sampling at this point. We collected information on water quality both in the field by running water through field meters as we pumped it, and by sending samples off to the laboratory to get laboratory analyses. So we're reaching conclusions. First of all, the area that we studied in 2014, we had conclusions at that time based on what we saw with 3 monitoring wells installed. First of all, we defined the thickness of the aquifer at that point. So this is about 3,000 feet out on the peninsula in the Acapesket South area. We had a 50-foot thick freshwater lens, and we found salt water beneath. The chemistry in the freshwater was generally conducive to treatment. Nothing that would prohibit it there. Based on the information that we had at the time, the concentration of nitrate out in that area appeared to be very low. We had low concentrations at all 3 wells that we installed, and one of those wells was a multi-level well. We found that the groundwater velocity was quite slow out in that area, about 0.1 feet per day of horizontal movement. And we found relatively low nitrate concentrations. So those factors combined tell us that this isn't necessarily a very good location for groundwater treatment with a PRB. We went back to the site in 2015 and we installed an additional monitoring well here, number 5. It's a little bit closer to Great Pond than any of the other wells that we had, and it gave us some good information. We were able to, again, map the water table based on elevation of water in our wells. So we survey in the location and top of casing of wells, measure down to the water table to within 1/100 of an inch, and then determine the contour of the water table, the actual contour out in this location. Turns out it looks a lot like that conceptual model that we showed earlier. We had flow in this area to the northwest with our data in 2014. We had some refinement of that with the groundwater flow turning more westerly as it approached the coast. So the additional well gave us a bit more data to refine that direction of groundwater flow. The 3 wells that we sampled in 2014 got pretty much the same results. We had low levels of nitrate in all 3 of those wells, including the multi-level well. When we sampled the new well, we found very high levels of nitrate. So completely different concentration, just happened to be based on the location. So one of the conclusions I reached here is that there's very different information depending on where you look. And these septic systems out in the area will generate those little plumes of nitrate as we showed in that conceptual picture. And if your well hits it, you see the concentration. If you don't happen to hit it, you don't. So it's hit or miss out here, as far as finding the concentrations. But actually, the highest concentration of nitrate in any well that we found in this study was in this number 5 well. And we found that concentration at all levels in the fresh water. So 3 different screens at this location, screened in fresh water, had high levels of nitrate. With a little bit of investigation, I found out that there is a septic system not too far away from where this well is located. So we're within that plume zone that arises at that septic system. So we have a bit of a change in our conclusions in 2015 for the Acapesket South area. Most things are the same, but now we find that we have relatively low concentrations in most locations, but a very high location, 14.7 milligrams per liter, observed at the highest concentration in the number 5 cluster of wells. The groundwater velocity is still slow, so the conclusion for this location doesn't necessarily change. It's still not necessarily a good location for groundwater treatment because the mass of nitrate moving towards the Great Pond is still relatively low over time. Doesn't mean there isn't significant nitrogen getting to the pond, but it's not generally conducive to treatment with this kind of system that involves flow through a treatment area. For the Acapesket North area, we put in a number of wells focusing on the Zero Shorewood Drive property, which is at the corner of Shorewood Drive and East Falmouth Highway. We put in 3 shallow water table wells, not just on that property, but in the surrounding area. And we put in 2 multi-level 2-inch diameter monitoring well clusters, one with 4 screens, one with 6 screens. And then the USGS 14-point multi-level sampler went in on that property as well. So here's the plan of that area. You can see that we put in wells up in this area to the north. There were some existing wells over here, number 11 and 12, were already in place from other investigations that had taken place out in this area. And we put in these wells on the Shorewood Drive property. We put these wells in 2 stages because we first wanted to collect information on the direction of groundwater flow to then plan where to put the second set of wells so we'd get the best information in this investigation. And what we found was the flow was to the southwest towards this part of Great Pond, the upper reach of Great Pond by the Coonamessett River. That is the flow that we would expect based again on that conceptual diagram of the groundwater elevation contours. And we also found that the groundwater flow up here is significantly faster. As we saw with those contours being tighter together, it's a good location for faster groundwater flow. So the flow was to the southwest, and that velocity, the groundwater velocity, was between 1.6 and 2 feet per day, based on the gradient that we observed and the permeability of the aquifer material, which was generally medium sand. We didn't encounter any layers of low permeability in our investigation, and we went down to about elevation minus 60. So what we found here in the north area is that we have geochemical conditions generally conducive to this type of nitrate treatment that we're considering. We found significant concentrations of nitrate over a wide area. So not just spotty hit or miss, but pretty much every well that we put in, we had very significant nitrate concentrations. The vertical distribution of nitrate in groundwater is significant, but it's limited to depths that are accessible for nitrate treatment. And we have a fairly well-defined bottom of the nitrate plume. So we know how deep we would have to go in order to treat it in this area. Now these slides, these graphs show concentrations in a vertical profile, and I'll show you this in more detail in a moment. But this is the vertical depth, it should actually be elevation, and this is the concentration of nitrate. So you can see up near the water table at the top, in some cases there was a little bit lower level, higher concentrations reaching a peak, and then it tapers off, and by the time we reached the bottom of our investigation, there was very, very little nitrate in the aquifer down in that deep zone. This chart is for number 4, which is the USGS multi-level sampler, so we have a lot of data points to give us detail on this profile. These are the 10-foot screen wells, so each point that you see here represents the middle of that 10-foot screen. So it's a little more like looking at an average. And this is the number 9 well, this is the number 6 well. Looking at those same charts closer up, the profiles, you can see the concentration of nitrate across the bottom. The top of that scale is about 14 milligrams per liter, and we investigated down to about minus 55-foot elevation. So we have a pretty significant thickness of aquifer, but we have a well-defined bottom, and this is within a depth range that would be feasible to treat. So that's one of our conclusions. The fresh water in this Acapesket North area is more than 60 feet thick. We didn't encounter any salt water to the extent of our investigation, so we stopped drilling before we got to that depth. I would expect the depth to salt water to be well over 100 feet in this location, if it's there. We found, again, conditions in the geochemistry conducive to treatment. We had this significant nitrate concentrations up to 11.6 milligrams per liter on the Shorewood Drive property. The base of the plume, as I showed you, is well defined. Groundwater is going fast, so we have that up to 2 feet per day groundwater velocity, which is actually quite fast for groundwater. And that high concentration and fast flow gives us a lot of flux or a lot of mass of nitrate moving towards Great Pond through this area. So that's really what you're looking for cost-effective groundwater treatment. You need to have a high concentration, fast flow, so that when you build a system, it's removing the most mass. And ready for questions.
Very good.
Question?
Can we start down this end?
Start
today?
at this end,
Okay,
absolutely.
great. You said more than once, you made the point that conditions were or were not conducive chemically for the treatment of nitrate in groundwater. Could you just elaborate briefly
Sure,
on what
yeah.
you're looking for?
So when we look at the geochemistry and the conditions conducive to this, we need to consider what's going on with the naturally occurring bacteria that's present at the location and what's going on with chemistry and the different concentrations. We found, for the most part, the groundwater is aerobic. Now, that's not necessarily an ideal thing, because in treating the nitrate, we'll need to remove the oxygen in the process. So there is not oxygen there, and that's called a competing electron acceptor. Nitrate is also an electron acceptor, but that's our target electron acceptor. That's what we want to be the compound of choice for bacteria to respire. So in their metabolism, they may use oxygen, aerobic bacteria use oxygen, or denitrifying bacteria use nitrate in the same process in their respiration. Once the oxygen is removed, we'll be able to stimulate the bacteria that denitrify. So that's our main target. But when we add an organic substrate to stimulate the bacteria, we can stimulate other bacteria that compete with the process to degrade the nitrate, for instance, sulfate-reducing bacteria. So one of the main things we were looking for here is relatively low levels of sulfate in groundwater, and that's what we found. We found generally around 10 milligrams per liter of sulfate, not real significant to be a competing electron acceptor in the process. That's one of the main things. We still will have other competing electron acceptors. We'll have iron and manganese, which is present as material actually attached to the sand grains that will also compete in the process. But I think generally there's nothing here that indicates that it wouldn't work. The pH is within a range that's acceptable. The sulfate levels are relatively low. Oxygen's present, but we always expect that to be an issue on Cape Cod.
And when you said you would have to remove the oxygen, were you referring to some process, or were you referring to the oxygen would have to be removed bacterially initially before you'd move on to the nitrate?
Bacterially, yes.
So you wouldn't try to remove the oxygen in the process?
No, not chemically, no.
Right.
So the oxygen would be consumed by aerobic bacteria at the start of the process, using the carbon that would be added for the construction of the PRB. And once those aerobic bacteria are gone, they're quiescent, they're dormant because the levels of oxygen are down, then it's the right conditions for the denitrifying bacteria to become dominant and degrade the nitrate.
Okay, thanks.
Oh, thanks, Eric. Hi, Jim. Excellent presentation. Thank you. Very clear. In looking at, I went through all the data, which was a challenge considering the time crunch that we had,
Right.
and I did some statistical work on it as well. But it's a little, but basically I found that in the south area there are two anomalies, from my understanding of everything you've just said, basically.
Okay.
And one of them is well number one. And I would have expected that one to be a higher concentration because it's right in the middle of the peninsula. And just like in the upper reaches, it isn't near the edges so much where, as you showed, the low oxygen in the groundwater is almost zero in the salt part of the groundwater, the sub-aquifer really. But in that, then I looked at the other maps. I looked at the watershed maps. And it turns out that well is like right on top of the boundary, or right at the boundary between Green Pond and Great Pond, in terms of the MEP delineation.
Right.
So it's like, basically, everything's moving away from that point, in the two directions. So you don't get any compounding effect that might be further down in the groundwater flow.
One of the flow that you would expect in that area is likely quite vertical because it is near that divide.
Okay.
I was kind of aiming a little bit towards the Great Pond side of the divide, but that divide probably shifts around.
Well, yeah, right.
It's hard to define exactly where it would be.
Yeah.
But that's one of the reasons that we selected that location for the multi-level well, because there's a good chance that the direction of groundwater flow at the highest point in that part of the aquifer is actually vertically down and then out towards the coast on either side.
Right.
So by putting a multi-level well, we'd be able to see what the concentration would be. But the flow, there aren't a lot of sources of nitrate up gradient of that unless you were drilling right through a septic system.
Right.
One of the findings in this study was of interest to me because at the Monitoring Well 5 location, which is over towards the coast,
Right.
even though we had a well just across the street, let me back up to that.
Right.
Yeah, this is my second.
Okay.
Okay.
So we had well number 2 right across the street here. It's not directly up gradient necessarily, probably not directly up gradient. Why such a difference between here and there? And the thing that was curious about well 5 is we had high concentrations at every level in the fresh water. And to me, there's something going on here because the groundwater velocity is quite slow, as I said. So groundwater's not moving horizontally very quickly. But where you have a septic system and constant flow, you have some mounding that occurs. And that mounding may be almost more significant than the natural gradient, probably is more significant than the natural gradient. And you could have some vertical migration close to a septic system that could account for what we're seeing there. I don't know the answer to that, but it's a possibility.
Right.
Before we go on to your second point,
Yeah.
can we just say one more thing about monitoring well 1? I was there when you were drilling it, and there actually, to the right, is actually sort of a park. I mean, it's all woodland.
There's a little bit of woodland there, right?
Yeah,
in the
there's
center.
only one house, but this slide doesn't show it, but it actually extends to the north and to the south. So not only is it near the top of the water table, the divide between Great Pond and Green Pond, but it's also in an area where you would not expect to find a lot of nitrate anyway, because it's mainly wooded and
Right,
it doesn't
yeah.
appear to have ever been developed.
There were a number of reasons why that location was selected, and getting the information on how thick the aquifer was near the center was a
Was
key
it-
piece of information that we wanted.
Yes.
Yeah, okay, then my point, the other anomaly which you've talked about, which is 5, which is completely different from the others, so as you say, hit or miss, but some of these look pretty close to clusters. But what I was wondering is that possibly near that one, it have to be checked. Well, you said there's a septic system near all these really, but is it a Title V, or is it a cesspool? Because I'm just wondering if you
Yeah.
happen to hit near a cesspool, which they're not, I don't know how many there are, but that might have been more of a factor. But then I also didn't see much ammonia. So you're getting pretty
Yeah.
good
There was a little bit of ammonia
nitrification.
there.
A little bit, yeah.
Yeah,
Not much,
which we
though.
didn't see in many places.
Yeah, right.
But
That,
at that location, there was ammonia, the conductivity was slightly elevated, and the chloride concentration and sulfide concentrations were slightly higher than the other wells in the vicinity.
Oh.
So we saw other indicators that there may be some wastewater, affecting those wells.
okay, and then the final thing is that it seems to me that from this data, I mean, as I say, 5 is a bit of an anomaly, maybe, in a way, but very clearly, the northern cluster was higher, generally speaking, than the southern cluster, except for this one, the couple of points on well 5. There were 2, I
Right,
think.
right.
But I think it says something. I'm going to give a little, my interpretation of some of this after this. But,
Sure.
But anyway, those were the main point. The only other thing I was wondering is that in your last report, you had calculated an estimate of the nitrogen quantity going through a 50-foot deep by 5,000-foot transect. But
Yes.
in this report, you
I did not do that.
didn't do that, right, for probably good reason. The more you know, the less certain it can be, right?
Well, it was, that was, to give you a rough idea of what it
Right.
might be like in that scenario.
Right.
But, you need sufficient information to put together the full picture, and we didn't have it then. We don't really have it now, but
Yeah,
they're, looking for a location to do nitrate treatment. Clearly, this location to the south is not as promising as the location to the north from a nitrogen loading reduction standpoint.
on that, I'll talk about this more, but later, but it seems to me a PRB may be more of a denitrifier because of anoxia than because of carbon. Carbon would be the thing that would drive it. I mean, that creating a low oxygen area
Yes.
through which would be more not for the nitrate coming in, but more for creating an environment in which the denitrifiers are happy to live there and will then be grabbing
But
the nitrate.
That's all very true, but the
Yeah.
denitrifiers also need carbon
Yeah,
for their
Right.
metabolism.
Yeah, they
So
do, yeah.
if they're carbon limited, they may not,
Right.
you may not have much denitrification even where you have low oxygen conditions.
Okay, right.
Interesting thing that we observed, and it's not data that's in the report because it's not complete yet in some of the work that USGS is doing, but in this figure, you can see the profile of nitrate at the USGS multi-level sample. And in sampling that well, the preliminary information is that they observed that their peak of nitrate was below the peak of oxygen. So the oxygen dropped off up here to very low levels above the peak of nitrate concentration. So where this peak of nitrate's actually present, based on the detailed data they could get from the 4-foot screening, they were able to see that there's a significant shadow of, if you will, of high nitrate below where the oxygen is gone.
Okay.
So it's an interesting thing.
Gobbling it up.
It really needs to be, in order for those bacteria to make a living, they need carbon and they need the nitrate.
All right.
So
In many instances, they're the same bacteria.
Right.
Bacterium can
it can
use
switch.
oxygen
Yep.
until it's depleted and then shift over and use nitrate.
Exactly.
denitrify.
Yeah.
Virginia.
Could you go back to
Steve.
your first slide? I just wanted to follow up, like a picture is worth 1,000 words.
First.
The USGS, I think it's, there we go.
Oh, yeah.
Okay. So the lower arrow would be more or less where the information from Acapescat South,
Close.
close, okay,
Yeah.
would fit. And the
It
upper.
was right about here.
Okay.
Yeah.
And then the upper arrow would be more or less the situation for Acapescat North.
Yes.
Okay. And so the only other point I'm going to make is that the upper arrow in Acapescat North probably includes a larger area of residents and long-term
So
living.
You could extend this arrow north for
Right.
a mile.
So you might end up with totally a greater mass of nitrogen that would be treated by a PRB there than you would at the lower arrow.
Fewer houses would be,
Fewer, exactly.
would
There
be
we go.
captured within the treatment zone.
Yeah.
Right.
The other thing that suggests, and I think we're about to have a major paradigm shift in how we think about groundwater approaching the southern coasts. That we always used to think of the Sagamore lens flowing north to south. And it's now pretty clear that these actual peninsulas act like little islands, so that the flow is east or west, depending on which
Once
side
you
of it
get a
you're
certain
on.
distance out,
And that,
yes.
and that the ponds, in fact, have acted as old river systems. And the water from the upper part of the aquifer funnels itself into those river systems.
Yes,
And then we get a huge concentration at the head of the coastal ponds.
yes. It's converging in that location. So convergence of water from a much larger area, moving fast, coming to a small area. It's a significant thing.
Steve?
In answering one of Ron's questions before, you referred to the early or rough estimate you made in the earlier report
Yes,
of the flux through a hypothetical 50 by 5,000 foot PRB.
yes.
And were you saying that now with this data, you would change that in any way?
I wouldn't have enough information to really change that, because, you know, what would you do? You could take an average of the concentration in the Acapescat South wells total?
I'm talking about Acapescat North.
Oh, okay.
That's where the calculation was done before.
No.
No, it's
No,
done
it's
for
done for
south.
south.
Calculation was for the south in 2014, because that's the only place we'd investigated at that point.
All right, well then I changed the question. If you did the same calculation at the north,
Yes.
how different would the result be?
The mass would be much higher. But bear in mind, you need to decide what's the length of that
You can't fit in as
area
long a one.
that you're measuring. So in order to calculate the flux, it's like you're taking a plane. So this is the water table.
Yeah.
This is your aquifer. In that previous report, this was 5,000 feet across the plane and down a certain depth. Up at the north area, given the way we've monitored, we're focused in on a much smaller area in general, you know, representative of a much smaller area. But it's an area that has a much higher concentration. So for a relatively short length of flux, let's say at 300 feet across and 40 feet thick, which would be maybe what you would do on the Shorewood Drive property, you would probably have a much higher mass than along the full 5,000 feet of the outer part of the peninsula. If you calculated the flux, it would be much higher. Because the concentration is much higher and the velocity of groundwater flow is much faster. So the water moving through that plane is carrying a lot of mass and it's moving quickly.
Any other?
Well, I was just going to say that I did averages of all, just took your numbers and played with them in a couple of ways. And, you know, the north was about, an average of about 4.7, and the 4.7 milligrams per liter nitrate, all I looked at nitrate. And the south was about the south was about 2.7, so. It's, but that included
if you were doing
that
average,
included the well 5,
Yes.
which is
That kicks it up a lot.
kicks it up a lot. But I did the medians then, and the medians were significant, well, somewhat less. Actually, the south was less than 1, and the north was about 4.67. It sort of was the same. Mainly had some few points
Right.
up there. Some wells just had 1, you know. So,
Yeah.
Any other comments or questions from?
I just have one comment, and it goes back to John Waterbury saying, you know, we might have a totally different concept developing here. You remember that Pio Lombardo's proposal was to ring Seacoast shores, and you could just take Acapescat instead and say, you know, ring it, and you can see that you would end up with actually a fairly small mass of nitrogen compared to what we're looking at now up at the Route 28, actually, intersection, where we've got a lot more groundwater coming up.
Right.
Any comments or questions from the public? Michael McGrath.
Can you go up to the podium so we can record you for the nationwide viewing audience, Mike?
And Matt, could you turn the...
Unaccustomed as he is to public speaking.
I didn't see the beginning of it. I'm sorry that I'm late, but I saw some of it, and it seemed that the plumes were quite deep. So there are ways to tell where those plumes came from. Are they from agriculture or from septics? And that might be critical. The other thing is that I live next to West Falmouth Harbor, and I've harassed some people. And I got a USGS guy to tell me how deep in the groundwater he thought it was coming up. And so it was over 20 feet. So that's a 4-foot rise and fall. We have a very shallow rise and fall here. So it might be good to find out how deep the flux is. Perhaps some of that nitrogen is actually going to flow underneath the estuary and go out. So that's my 2 points. Remember, a home wastewater plume is very shallow in the ground.
And narrow.
It's narrow and shallow. Yes, both. I did some calculations. It's much less than a foot, so it's easy to miss. So.
Jim, any response?
One of the points made, I think, was that the depth of Great Pond is 10, 20 feet at the most. Probably 20 feet would be a big hole.
Mm-hmm.
Yeah, it's less,
It's
16.
less.
It's like 6
15
feet.
Yeah.
So
Six
you can
feet.
see that much of the nitrate concentration if you looked directly sort of in the same plane up into the aquifer, is at deeper elevations. I think that it's difficult to say exactly where that's going to discharge into Great Pond, but often the flow at the surface water can be up into the pond. Chance of underflow is a potential and going further out, but quite often it's up into the pond. And one of the major things that went into this USGS modeling was a factor of how easy it was for the groundwater to discharge through the bottom of the pond. And this is the scenario that the modeling showed. If the pond bottom was quite porous and that deeper groundwater could flow up into it, it would result in this picture of the contours. And if the pond bottom was very tight, which would tend to drive the flow further out towards Vineyard Sound, the contours on these peninsulas would be very similar to what you see up here. They would be across the peninsula with groundwater flowing this way. And that's not what we observed in our assessment. What we observed in our assessment really supports this picture. We had flow up in this area was as this arrow shows, and the flow down here was similar to what this arrow shows. So chances are the bulk of the groundwater discharges to the estuary and not further out to sea.
Just to add to that, in West Falmouth, they found the same thing, that in West Falmouth Harbor, the monitoring wells, that there is not an expectation of underflow, but there's a sort of an upwelling at the surface, and if you go around there in the summer, it's really warm water, except for at the bottom when it's 50 degrees, so you know that something's going on.
Any other comments from the public here? I note the presence of Doug Brown, who lives in Anacapesky and has been very helpful to the town and to the committee in moving this project forward, and we thank you for that. And,
Can I say one more thing?
Sure.
I think we all know that the edges of the estuary, it doesn't freeze. When I was doing the Little Pond Landing project, there was always at least 2 foot of clear. But I do a lot of pier work, and a lot of these bottoms are getting to be coated with an anaerobic ooze. So
The black muck
he
problem.
doesn't perhaps he doesn't know, but I'm a local land surveyor, civil engineer, plus I know how to remove nitrogen from water in wastewater treatment, not in the groundwater. But I just want to make those observations that our bottoms are changing, and there's some significant black ooze around several of these estuaries. And once that ooze is in place, it's not going to come up from the bottom, it'll come up from the sides. And it doesn't boil. I don't see the springs on the east side that I see in West Falmouth.
Interesting, yeah. Okay, any other comments or questions? Do you have a, sure.
Okay, I'd like to see if we could vote to accept this report and approve it so that we can.
Is that on the agenda?
Yes.
Oh, good.
It's
Okay.
to, yes, to vote.
Yeah, good. Okay.
I didn't hear any corrections of any sort to the report. So I would
Is
move
that
to
the
accept
motion?
the report.
It's been moved and
I'll second.
seconded to accept the
No,
report.
I just have
Discussion?
one suggestion, which is, it was actually corrected, I mean, in a way. I mean, it wasn't a problem, it was no error, but you had 2 of those graphs.
Yes.
They're on different scales, but then you put the right scale where you combine them all.
Yes.
So it was the same scale.
I noticed that.
So it was hard to, when you first looked at it, it wasn't that different, but it was, but.
The charts that are posted on the figure.
Yeah,
we
right,
can
right.
fix
But the
that.
one where you put them all
Yeah.
together, it was.
Yeah, well, we can fix that.
Okay,
Yeah.
all right.
I'll be going through and, any
Yeah.
edits that you have, be happy to
Okay.
make corrections, and that's one that we'll
Okay.
definitely do.
Yes, Steve?
I'm certainly in favor of accepting the report. I just want to make it clear on the record that this is in no way saying that we're saying that PRBs make sense. I mean, let me be careful with that word. That we are saying to definitely go ahead with building a PRB.
No, you're quite right. It's
And we're
it's the
accepting
kind of
it.
There are a lot
information we
more
need
questions.
to get to that point, but we're certainly not there at this point. I would just note before we vote, that this project was started in Falmouth, initiated by this committee, and the United States Geological Survey and the Environmental Protection Agency have glomped onto it as a place where something is actually happening, as opposed to more papers being written and regurgitated. Falmouth, once again, is at the cutting edge of developing real answers to the nitrogen problem, and not just talking about it. And it's quite a tribute to this town that the biggest agencies in the federal government are asking us, how are you doing this, and can we help? I think the town should know that. So any other discussion before we take a vote? Okay, all in favor?
Aye.
Opposed? The ayes have it.
Thank you.
Thank you. Okay. Next item, groundwater discussion. We had a slide presentation at the last meeting, which we had to sort of end it there because we had a couple of other things we had to get out of the room, but Ron is back with the continuation of that presentation.
Jim, do you have all of your?
I think I was just looking, you already have it, Ron? Oh, yeah, I brought it over.
There it is.
I took it with me.
Clarification is cleverly disguised as your portfolio.
This will be, since last time I didn't really.
That's good. That's it.
Where it says slideshow? One, two, three, go to the right, right, no, that's the left.
Right
The
in
other
the
right.
middle.
Your other
No.
right.
Slideshow. And then from the beginning, which is over to the left.
Okay, thank you. Okay, I have basically sort of pulled together a lot of information from the great work that Jim's done, as well as some work that one of Ken Foreman's classes has done, and looking at the data that we've been getting and trying to get a sense of what's happening out there. And a lot of the factors I have in this have already been discussed. Now what have I done? Oh.
Here, want me to get it?
Oh, I see. Oh, okay. Thanks, Steve. Sorry. So in this then, I began to look at, let's see if I get, yeah, I just started to look at things and got, worked out that there are different new information coming up, and a lot of it has to do with really what's going on in the groundwater and what the hydrology is, and that there is, but a lot of the data is still incomplete, but there's some trends being seen, and we've been discussing some of those already, and that in the groundwater there could be very much a considerable denitrification going on as we know it, because of the low readings that are being seen in many areas. So the someday I'll figure out how to use this. So anyway, coming back to some basics in terms of groundwater flow, I went into the MEP reports, and I found that I did calculations on the mean volume of Little Pond, and then they had different sources of groundwater going in, and of water going in from Little Pond stream, from groundwater, from direct precipitation. But I didn't look at surface runoff because that might be double counting, because a lot of it percolates down in. But we get about 11 turnovers a year, just without any considering a tidal exchange, a year, just based on the freshwater volume coming in from the MEP estimates. So, and this gets into what John was pointing out, especially with regard to Little Pond Stream input and what's coming in from upstream. Now, this is a data set that was collected by a class at MBL that gave a summary in a class that Ken Foreman led that gave a summary at the end of October. And just in looking at Little Pond, the seeps, this is water coming in from the edges, which is what Mike was talking about, the way it flows up and in. He was getting readings of about 1 milligram per liter on the east side and 2 milligrams per liter on the west side. The west side is on the West Falmouth Heights side. So we're getting, in using this data and then looking at the volumes of water coming in, begin to get an understanding. Now I got out my crayons and did a drawing, okay, more or less. But this sort of gives an idea, and this is what I think might be happening to a large extent, and Jim alluded to a lot of this, but especially when we get into this anoxic area, just as it is in the estuaries, and it has been measured, we have a freshwater lens that thins toward the estuary, and the groundwater flows into the estuary, and with it, it carries the nutrients. But my sense, too, is that at this low zone, at the bottom, at the interface zone, where it's almost anoxic, and this part of the groundwater, the freshwater, is aerobic, and so you end up having an area where denitrification can be going on right on the pond, at the interface in the groundwater. So that moves along, and it thins as it moves. So there's more contact really with the anoxic area as it progresses in that direction. Now, coming back to what John was talking about, is that, like in Great Pond, about 50% of the nitrogen coming into the pond comes down the Coonamessett River. In Little Pond, about 35% of the nitrogen coming in comes down the Little Pond stream, according to MEP studies. So what we have here is that in those upper areas, the anoxic zone, or the low oxygen zone that's been measured, both in the northern part of Acapesket, is below where the groundwater flows into these streams and then contributes the nitrogen that's in the groundwater. So you have it flowing in, like basically creating the stream, some runoff, and you end up getting these this flow, this very high nitrogen concentration flowing down the river. And Asia was looking at putting filters or denitrifiers in the streams themselves. Well, these are possibilities. But this is basically the same phenomenon as we saw earlier. Now, in looking at it, and I know Mike has a lot of opinions on this, and a lot of PO does, and a lot of people do, but when you look at the carbon needed for denitrification, we have studies been done looking all across the United States, and they're finding the carbon to nitrogen ratio in the human waste stream is about 3:2. And the wastewater treatment, sorry, not plant is, this is from another study, shows that the optimal ratio for denitrification is about 2 carbon to 3 nitrogen, which means that there should be enough carbon coming in from the human waste stream to augment denitrification in the groundwater. And in a way, we're looking at, and then if we look at the data that Jim just presented and Virginia presented last time, we can see that phenomenon. In other words, at the lower part, we have very low nitrate. And it could be that that's near the bottom of the aquifer where the salt wedge is coming in. And then when you talked about oxygen being depleted, it could be that through nitrification of the plumes coming in, the ammonia and nitrate, and ammonia coming out of the septic systems, that maybe it's taking it up and creating the nitrate, and that's basically it. Now, what will happen as it moves to the shore is that basically all of that nitrate at that depth is going to be moved into that narrowing wedge as it moves out. So whatever is there in the left graph or the right one, you're going to have compressing it and putting it in more in contact with that anoxic zone at the bottom of the freshwater part of the aquifer. So
Oh, I did it again, see ya. Sorry. I know, this is scary, I know. There's only 2 buttons on here, folks. Okay. So, yeah. So anyway, so then I looked at the groundwater to Little Pond and used the flow rate that was in the MEP report. It comes out to be about 1.1 billion liters per year going in. And then I divided it in 2 and came up with these factors of about 1,656 kilograms of nitrogen, which is 42% of the MEP estimate coming from groundwater. And that is because just using those figures that they had, which corresponds with the low readings that Jim's group has come up with, it sort of correlates to that and to the MBL studies, which are also similar in the low 1 to 2 milligram range, because the MEP report basically has about 26.25 milligrams per liter as its estimate in its models. Now, can't get into the models, but these are the figures that are in that report. So what we have then is lower nitrogen coming from groundwater only, okay? So it's going to be quite a bit lower just doing the simple math. So according to these calculations then, and you look at the total inflow, adjusting, well, basically from MEP, and we get 5,336 is the amount that needs to be reduced to meet the total maximum daily load. With the new calculation from MEP, the amount is 3,059, needs to be removed. The sewer system is being put in now will, based on this, take care of the problem and more. So we know that possibly that 88% may be an underestimate of what the sewer system might do, but it's likely going to be also an overestimate. An overkill to some extent. I mean, we'll find out. But based on these calculations as we move forward, and as I said, that in looking at the MEP report, about 65% of the nitrogen in that calculation came from groundwater and 34% from the stream. So it could really be about 50-50 here if the MBL figures are correct. So it's about, there's a lot coming down the stream just by doing those calculations. So then again, to meet the TMDL, the Little Pond sewer service area could do about 134% of the job. And then I did an estimate of what oyster aquaculture might be able to do in there for the part of the year when nitrogen needs to be managed, which is in the warmer time of the year. Because in the winter, you go out there now, the water's crystal clear. It's full of nutrients, but they're not causing a problem, and about once a month, the total volume flows out into the sound. Now, this figure, this 500 kilogram figure, includes denitrification based on calculations done last year. Brian Howes has some new figures out. They're not finalized yet, but what he presented at the Oyster Symposium has it closer to 250 kilograms per acre. From what he presented there, but there were some anomalies I saw in the presentation that I think his final report will clarify. So it could be 5 acres if it were half of what was measured in 2014 compared to 2015 with regard to denitrification. So the oysters could really could basically take care of the seasonal problem, and then in the winter, though, there's no problem really. So it's, that would just flow out into the sound the same way that inlet widening will move more nitrogen out into the same way of basically getting it out in a way. So when I looked at it, and then you start thinking about this, and you look at this data from the upper watershed where you've got deeper water and possibly higher nitrogen loading coming into the Little Pond stream, this is an area that really needs to be addressed. These lines demarcate more or less the Little Pond watershed, not the Great Pond
watershed that's also going to be benefited by the sewer system. So what we have then is a lower, these peninsula areas. Sorry.
Don't spill on the new name cards, please.
Okay, I'll try not to. Thanks. Yeah, so anyway, it looks like if this is the case, and we do have this nitrogen removal through denitrification in an anoxic zone at the bottom of the interface between the freshwater and saltwater interface, this could be that as we move forward in considering the peninsulas and where the real nitrogen source is coming from, as John mentioned, a lot of it's coming possibly from upstream, especially the Coonamessett River. And then coming back to the Acapesca data, I went on to look at this and did the same kind of volume exchange per year. We get almost 10 volumes per year in the Great Pond from basically a lot of it's from the Coonamessett River and groundwater flow coming in. But this is a similar phenomenon where in the wintertime, the 60% of the nitrogen load will likely just flow out into Vineyard Sound with the inflows. So then I took the data from, I didn't update it with the new report, but I just used the old report from the Jim's old report and did calculations. And it looks like that if we use the MEP inflow rate, which is much faster than what we were seeing with what was measured by Jim's group, about the inflow would be about 80% of what of nitrogen loading from groundwater would be about 80% of what the MEP estimated, so it's pretty close. That's pretty close. But when we then take the 50 by 5,000 foot transect data, which was 140 kilograms over that, and the shoreline of Great Pond is about 30,000 linear feet as opposed to 5,000. So you take 6 times 140, and I think I got 840 correctly, which is again, a much lower, 10% of what the MEP estimate was with it's even, yeah, well, let's say roughly 10%. It's about 10,000 kilograms coming in. Oh, 9,973, sorry. So it's a little bit less, but anyway, so if this phenomenon is going on in the groundwater, and we'll start seeing some interesting phenomenon. Again, it reduces the. I did 2 analyses here using the 1.3 milligrams per liter with the MEP flow rates, and I ended up with a nitrogen reduction of 9.6. Again, it was pretty close to 11.6 because of the difference, and that would require about the seasonal load, possibly about 8 acres of oysters to take care of it. So, and again, based on the MEP report, it said 57% of the nitrogen is coming from groundwater and about 43% from the Coonamessett River. There is some surface runoff, there's precipitation, but it's not very much relative to these major loads coming in. So then if we go to the MTERB, which is the 140 kilograms for 5,000 linear feet, or 840 kilograms, we basically reduce the nitrogen coming in by about half, and we end up with an ATMDL of 8.4, and therefore only needing to remove 2.5 tons, which could be done with 40% of the area with 2 acres of oysters. So based on last year's data, or 4 acres of oysters, if the new estimates on denitrification are significantly lower in the end. So these are the phenomenon. So as we look at this and try to understand the groundwater dynamics and what's happening, and if in fact there is enough carbon there,
a PRB will work. That's what I was saying, is that if there's enough carbon already in the groundwater, the main thing is going to be, and we've already seen oxygen dropping, possibly due to nitrification going on, that we very well might be having a phenomenon with a PRB that it's more of an anoxic zone that actually takes the nitrate, it strips the nitrate down, because it's a habitat for bacteria that are functioning as denitrifiers. I guess that's a better way to put it, John. So, anyway, there's a number of pre-preliminary indicative findings. Okay, so these are.
What?
I'm not trying to make it anything, but I figured it would be better to do
Ron's
this.
musings, huh?
No, it isn't. No, it's based on pretty real stuff that's coming up now. But you don't want to, basically, we're not getting new calculations of what a 5,000-foot transect would do yet either, because we need more data to do that. But lower nitrogen concentrations have been consistently measured recently along the shoreline of Falmouth estuaries than assumed previously. Water sample measurements are from 18 sites to date. We've got more sites now, and many of them are still in that range, except we're getting up into that upper area that may be
Totally different.
More distant from the area. And then impacts from nitrogen pollution from peninsula and other nearshore septic systems may be much lower than previously assumed, possibly due to greater attenuation, denitrification, groundwater at the freshwater and anoxic saltwater interface. So anyway, this is what appears to be showing up in the real-time data. And then, and therefore, the more significant loadings may be coming from upstream or in the upper area rather than actually in the peninsulas because of this denitrification phenomenon. Shellfish aquaculture planting or reefs perhaps could very well help with a lot of that. More groundwater analysis is needed, especially along shores and things like this, to get a real handle on this. So, so in looking at this, I had some suggestions about where to take samples. Again, more water quality is needed. So, anyway, this is the Little Pond oyster, part of the Little Pond oyster aquaculture system. So that's it.
All right, thank you very much. Comments or questions, rebuttals, disputes, whatever, for the next probably 15 minutes, because we have a few other things to do tonight. Steve?
Ron,
Yeah.
when you were on the shellfish committee, planning the project for Little Pond,
Yeah,
there were, I don't remember any of the numbers,
yeah,
but there were predictions made about the effectiveness of that pilot project
yeah.
based on all the MEP assumptions.
Mm-hmm.
Now, if in fact the nitrogen loading of Little Pond is only 42% of those assumptions, then whatever oysters you put in there should have been 2.5 times as effective. Were they?
They might have been, maybe more. We don't know yet. But the thing is that we only had, if it takes 2.5 acres to do this, according to this.
I'm just talking about the pilot project.
Right. The
Hypothetically,
pilot project was based entirely on the nitrogen assimilation into growth. We didn't consider denitrification. We were very conservative on that.
But the observed change in nitrogen concentration in Little Pond should have been 2.5 times what you expected.
It probably was, maybe more.
No,
The
I
thing
don't-
is
I
that
don't
we have a
think so.
very low, a very small area, 0.3 acres versus 2.5.
All right.
So that's like 8 to 10 times. Yeah, sorry.
So Ron, the issue is what size oysters are we talking about? Because I think we've sort of been
Oh,
through
no,
this.
well,
That when you say 2 acres, how many oysters is that?
okay, well, in the case of Little Pond, I was looking at actually, that's a good question that we need to look at more carefully, but with the smaller oysters, we can get a lot more per unit area.
And they
Right.
have
Less than 2 inches.
1/100th of the nitrogen uptake of a full-size oyster.
Exactly. So you put maybe it's more than 100
that would go in, or the denitrification makes up for the balance, because denitrification could be 90% of what's taken out.
That's a
But-
big hypothesis
Yeah,
right there that
right.
we haven't
But-
really seen.
But you're right, the smaller oysters, I mean, it's geometric in essence, basically, in terms of nitrogen uptake. I don't think it's exponential, could not. I think
It's exponential.
Geometric. So it is, so it's the small ones. And I think a lot we were doing, it depends on when the calculation was done during that, but we were even thinking about 3-inch oysters at one point for the project, to grow them to 3 inches. But then we were basically advised, instructed by the Division of Marine Fisheries to grow smaller ones.
But in principle, you would have noticed that before Ken did his measurements.
We did.
You would have noticed, whoa.
We
this is
did
coming
not
at
have
2.5 times
any-
as much nitrogen as
The
expected.
nitrogen reduction from the Little Pond shellfish demonstration, there was no change. There was no change at the Sentinel station in terms of nitrogen concentrations. The only thing that changed in total nitrogen only changed because the particulate organic, we've given this presentation twice from 2 years of data. What we saw as a localized change was a change in water clarity because oysters filter and they take up the particulate organic
Right.
nitrogen fraction, which is the chlorophyll fraction, which is in the algae. But the nitrate concentrations and the total nitrogen concentrations at the Sentinel station, which is right there, did not budge.
But, well, the thing is that we have about, let's say about 0.1% of what the oysters eat become oyster. Okay, it's very low. And so it is, then you have the fecal matter and you've got the denitrification side of it, and that's where the real story is at this point. It's something we didn't factor in because we didn't have data and now we're getting a database that supports that. To what extent, we're not 100% sure yet.
But
So-
Ron,
Yeah.
Yeah, let's get some.
the water
additional-
quality sampling isn't showing anything.
Well, it's,
The
well,
other
we got,
thing
we've
that
got
have
nitrogen removed in oysters, and we got measurements of denitrification. That's what we have.
All right, John.
Yeah.
The other thing you have to remember, Ron, is that at the very best, you might get 50% natural remediation of groundwater from the source to the pointed outflows, and that's being really generous. It's generally accepted that groundwater is carbon limited. So the reason that we have all that nitrate laying around is because there's no carbon to drive it into gas.
Well,
And
yeah.
if
John,
you-
John,
if
the
you
important
just-
thing
if you
is-
just
Yeah,
look
why
at
don't we
the-
let John
If you
talk
just
now?
look at the load on the
Yeah.
peninsula, every human excretes 2.4 kilos of nitrogen per
Yeah.
year. We have a pretty good idea how many humans there are sitting on these peninsulas.
Yeah,
And if you say, okay, I'll give the groundwater the credit of 50%, there's still a hell of a lot of nitrogen that's getting to those ponds that we
Right.
have to account
okay.
for.
Thanks,
And
John.
there's no getting around that.
Well, the only way to get around that is to look at the facts and the data. And the data is showing much lower nitrogen concentrations in all of these studies than even at the highest level, it's half of what you're saying. So, and we're getting, generally speaking, much lower levels. This is what we need to look into. I'm not saying this is certainty. You saw the way I described it. But what you're saying is based on some generalization. There is no basic data that shows that this 50%. It's an assumption, it's considered possible, but we're not seeing that in the data.
All
May-
right.
may I-
See ya.
There's one other thing
Yeah.
in your calculations. If you look at the MBL data, it's only nitrate. And it is well
Oh, no,
understood.
it's not ammonia too.
It's well understood that there's a TKN fraction, and then there's an organic fraction typically in groundwater. In fact, there's a couple of seminal papers where it's ammonia nitrate, they say total nitrogen measured, but I asked Ken about it.
Yeah.
They do not do the lab analysis for total nitrogen as defined in the MEP. The MEP report has a QAP, which is a quality assurance plan, and they measure nitrate, ammonia, dissolved organic, dissolved particulate. I mean, there's a number of different fractions, and about 50% is everything but what's called the dissolved inorganic fraction, which is what Ken's group measured. because that lab analysis is too expensive.
Well, it's not that difficult to do it, but.
But they
the
didn't
thing
do
is
it.
They didn't,
that
so
most
these
of the-
numbers are
no,
about half
no,
of the
most
total
the ni-
nitrogen.
Most of the nitrogen that goes in, and if you do total, total killable nitrogen assessments, it includes particulates as well. And those particulates are going to be either captured in the ground or not. Most of what flows in is the dissolved nutrients.
The MEP estimates are for total nitrogen. You are looking at dissolved inorganic nitrogen. There's about 50% of the total nitrogen number missing in these.
Okay, all right. well,
They're just, they happen to not be there.
Let's say you're correct.
So it's important to
Yeah.
include them. I'm just saying, we
I'm-
have to look at the
right,
facts,
I think
and
you're
that's
right, but
a
if
big
it's
one.
half, then we're going to 2 or 4. So that's okay. That's all right with me. I mean, 2 or 4 is much lower than 26. So anyway, through the chair, yeah.
Sure.
Yes, Pam.
Yeah, I was just wanting to follow up on your question.
Pam, you need to stand at the microphone.
Oh, sorry, yeah.
Everybody at home can hear you.
Yeah, so this is the first time I've come to this meeting, so I'm trying to listen a lot. But I was just following up on the question you made about what is not being measured, and I was wondering, would that also indicate, say, the role played by fertilizers applied by people who are living on these?
That's a great question, and the estuaries project includes a calculation for fertilizer load and stormwater, so they call it impervious surfaces. So those numbers, these reports have gone through a lot of iterations, these things called MEPs. And they do have the fertilizer and the stormwater and anthropogenic sources, or the atmospheric deposition and other things.
I see. So
But that's-
measuring that is really a matter of what is financial? Because you said that.
Well, no, they're
No,
measured.
they were measured.
They are measured.
In-
They're included.
Oh, I
in the-
see. I just heard someone.
Well, the
mention that they
financial
had
piece
to-
comes from, there were some students this summer doing a sampling project, and they had an extremely low budget. I think the whole project was $2,000, which this committee paid for. But there were lots of things that didn't happen in that study, because it was basically an academic exercise for these young students.
I see.
And so that's what she was referring to, the results were not
I can
complete.
elaborate a little bit.
Thank you.
That's a good question. The only thing I was looking at here was groundwater contribution. I was just looking at changes in that. And I think, what is it, the fertilizer contribution is like 4 or 5% maybe, and the atmospheric deposition might be 1%, so, of the total. So we're looking at, the main ones, again, are the groundwater inflows and the tributary, with our tributary inflows. And they vary, everyone's different. So that's why I specifically looked at 2 of them using the Acapesca data. So you're right to raise that point, but it's relatively insignificant, and this wasn't looking at that particular aspect. It's just looking at really the changes in groundwater because of the new data that's coming in.
Virginia.
Thank you.
Ron, I'm glad you wrote pre-preliminary as your
Yeah.
sort of conclusions on this. I think it's important for all of us to ask wide-ranging questions and to be probing. But I think we have to admit that you had data from 18 sites, which is not a lot of data.
That's
and-
18 more than we had before.
Well, so that's what I just said. It's important to ask questions, but we have a limited amount of data from which you're drawing some pre-preliminary conclusions. If you look at Acapesca South, we had a total of 4 wells.
Yeah.
Okay, 1 showed very high concentrations, and we have reason to think, and that's the most recent one, well 5. We have
That's-
reason to think that is near a septic system. And I'm sorry Mike McGrath has left, but he has always emphasized that these plumes are very narrow out of the septic systems.
Right.
So unless you have some really dense wells at multiple levels, you could very easily miss where the nitrogen
But-
sources are. So
Right.
all I'm saying is that we have to be really careful with the things that you put out.
Yeah,
because
and as
knowledge is too limited.
should we all, really. And that's why I'm being very cautious about this. But what I'm saying is that even if it were 8 as an average for well 5, even if it were 8, it's still less than a third of what the MEP reports assume. So it's just that, and that one, if we've got all these other points, that means that we've got certain little plumes coming in, and a lot of plumes with very little in them coming in. And if you take that and look at it at the total groundwater flow coming in, it could be, in this case, it's 25%. In a way, the 4 wells, okay, for 25%. But it could be very well that there are much more groundwater coming in at lower levels than at the higher levels. We don't know that, and that's what Jim has pointed out.
We don't know.
Yeah, we don't know. But what we do know is that what these measurements are. That's what we do know. And they're showing a real trend at this point.
All right, any other comments or questions from any members of the committee? Any comments or questions from any members of the public? Douglas Brown.
Hi, Doug Brown. So it seems that this, to me, what I'm seeing just from a quick glimpse here today, it shows what we had suspected previously, that the majority of the nitrogen is coming from further up in the watershed, which I thought we already knew that. So
Not quite.
is that not the
Well,
case?
no, we assumed about, as I pointed out in the MEP reports, if you look at that was CEO calls it the rainbow table, you can look at it, about half of the nitrogen is coming from upstream and half is coming from the peninsulas.
Right.
So it is a lot. And in Little Pond, it was actually about 35% from upstream.
Yep,
and
I got that
and
part.
65%. So, yeah, but it was significant. But then, as we've always talked about, before the oyster thing came in, really, or to an extent, or even inlet widening, and many of these things, controllable nitrogen.
Mm-hmm.
And that's where where people previously, before we got into looking at the alternatives, were looking specifically at controlling the septic load, because that's what the people thought could be controlled. So, and with eco toilets or denitrifying systems, septic systems, or whatever. Yeah.
So that was very interesting, the well sites and the discussion about the potential for the possibility of a PRB. Do you have other well sites in other areas that you're working on?
Well, that could actually segue into my report.
Yes, actually,
Okay,
we
all
do.
right, well then,
All right, do
We
you have
do.
any other questions?
no, that's it.
Okay,
thanks.
Yeah,
yes,
stick around, you'll get a good
Okay.
answer to that one.
yes. So you want me,
Yeah, at the-
reports of members and staff?
well, we got sediment removal project discussion and vote, so let's do that.
Okay.
Okay, quick one on the sediment
Really quick.
removal project.
So Ann Giblin was here on the 29th presenting a project for muck removal. We just heard about how the muck's a problem. It's a sediment aeration project with diffusion. And a new grant has become available. It's the Southeast New England Estuaries Grant. And the Division of Marine and Environmental Services would like to apply to do that project as a project of the town. So what's coming before this committee is before you voted to support the MBL, to be a partner with the MBL, to submit a grant for this project. And so now, since the Division of Marine and Environmental Services is submitting it, it would be a vote to, instead of supporting MBL, to support the town. So that's the request. It's just to change who you're supporting in pursuing that project.
Are these two entities competing?
No. MBL is
They're
not,
collaborating.
yes. MBL is going to do the monitoring, and the town would do the implementation.
I think there's another reason for this, which is MBL may have other projects that they'd like to apply for, and they can't apply for more than one. So the applicant here will now be the town of Falmouth.
That's right.
But the players will all be the same.
I think it'd be good to get a copy of the proposal to look at it a couple of
It's the
days
same
ahead
one
of
you
time.
already approved.
Yeah, same one.
It's the same one?
It's the same one, it's a different applicant. That's the only difference.
It was $50,000 before? It's a $50,000 grant
No, it
proposal,
was
right?
a $200,000 proposal to the Southeast New England Estuaries project. And MBL and Ann was going to be the applicant. And now it's the same project with the same scope of work and the same budget that would be a town project. And the request is for the Water Quality Committee to endorse, to partner with the town on this project, as opposed to partnering, as you've already voted, with the MBL.
Okay, can I get a motion on the floor from somebody to, Matt?
I move approval.
Okay.
Second. It's in the minutes of October 29th.
That's right.
Which we're
Yeah.
about to approve, Ann Givlin's project
Right. Okay.
is there.
Discussion? Steve?
And Ann Giblin and the MBL are in favor of it.
Yes,
So, in essence, be a subcontractor.
yes. They'd be the
And
monitoring.
because they'll still be involved.
Absolutely. Oh, yes. Anna's group is going to do all of the monitoring to determine what's happening in the benthic, in the sediment because of this technology, which is what was going to happen before.
And is the town contributing some in-kind resources?
Project management, budget, just overseeing the grant, and supporting the installation.
But no money.
So what's in it for the MBL?
Money to do the monitoring and plenty, like 2 PhDs out of it, at least.
No, I mean to do it this new way as opposed to the original way.
So that they can apply for other projects to SNAP. SNAP has a requirement that an institution can only get one grant.
Okay, I understand that.
So that's the reason for the
Yes,
shuffling of the
yes,
chairs.
Okay, that's
Okay.
fine.
Further discussion? Okay, all in favor?
Aye.
Opposed? The ayes have it. Thank you very much. Report of members and staff. Virginia?
Okay, this is about Fisherman's Cove and a grant that the town has received from the EPA to do groundwater investigation. This is the Davisville Peninsula. We heard today about the Acapesca Peninsula, but it is the same concept of trying to find the saltwater-freshwater interface, looking at groundwater quality, looking at groundwater direction of flow, and then ultimately calculating whether we have a flux, a total mass of nitrogen, where a PRB as a technology might make some sense. The grant was awarded in August, and so I'm providing an update. The subcontractor to EVA is called Water Vision, and they were here this week to actually plant the little flags where the wells will go. We have a possibility of 7 wells. Most of them will be water table wells, but at least one location will be multi-port, multi-level wells. Dig safe is the next micro step that needs to be taken to make sure that we're not going to conflict with any particular utilities. All of these wells, with the exception of one, are on Sailfish Drive. And then there's an upstream well that's on Tarpon Road, which is just to the north of Sailfish Drive. And if all goes well, the drilling would take place in January. 1 or 2, possibly, wells were just within the 100-foot buffer zone of Bourne's Pond, and so as a precaution, we filed RDA, a request for determination of applicability, with the Conservation Commission for up to 4 wells along that area where we might be within the buffer. And the Concom voted this week that we can proceed, that there is no environmental issue. And so at this point, Water Vision has all of the technical information that they requested and that the town was required to provide.
Questions or comments? This is very good news.
Yes.
Congratulations.
Yes.
Any other report of members or staff? Steve?
I would like to propose the creation of a new working group, which might be called Streamwater Remediation. Another title was Synthetic Constructed Wetlands, but Sia came up with this Streamwater, and I like it better. And in the last 2 or 3 meetings, it's become apparent that the nitrogen input from the streams running into some of these estuaries is the 800-pound gorilla, or at least the 350-pound gorilla, and of nitrogen contribution to the estuary. And Sia mentioned one method of attacking that, I have another speculative method. I talked to Ken Foreman at the MBL about it, and he improved on it, and there are others in the literature, and pilot projects for these could be done on very small scale in plastic drums, and because they're scalable. And so I think that we would be remiss not to look at that. So I'd like to know if that's all right with the committee and who would like to be on it.
Well, whether it's all right for the committee is tonight's question. Who would like to be on it? I think we'd probably want emails from members who would like to be on it, rather than just jump right away here. Comments, questions, ideas?
Well, I absolutely agree that streams are a component to the nitrogen input that was never really sized up. And the charge of this committee is to look really widely at ways of solving the nitrogen problem. And absolutely, I think a working group would be a good idea.
I concur.
Yeah, this is one area where there aren't consultants out there who claim to be experts at it.
Not yet.
Yeah. And that's one reason I think it hasn't risen to the top of the list, in the list that everybody makes.
Right.
I think three of you actually worked on this idea in the review committee, when you were looking, I think, at the cranberry bogs and
Yes.
upstream of
Yes.
the Coonamessett.
It's-
It never got to the front burner because we didn't quite know what to do or
Right.
whatever, so.
Yeah.
Right.
But it has been explored, and as kind of using a wetland technique for capture.
Wetland
or
concept.
concept. And so I think that, yeah, I mean, it's worthwhile. And in-stream could be, I'm not sure exactly how that'll work with all the conservation issues, but it is something that,
Sure.
that, you'll see how far it can go. If it can help a lot, then it might be worthwhile.
Well, I'm hearing a consensus that people want to do this, and why don't we just, anybody who would like to be on such a subcommittee or a working group, I believe was the phrase,
Yep.
email me or Sia, and we'll see who wants to do it, and do it. Okay, I've got a couple of items. Do you have any more? I'm sorry. Okay. The $10,500 that Falmouth voted, the Falmouth Selectmen voted for the Quashnet project, was matched by the town of Mashpee.
Oh, good, great.
They've stepped up, so we now have the full funding necessary for that project to proceed. The other report, I guess, would be the Boynes Pond notice of project change. This is a phrase the state uses. We're not changing the project in any way, but it's their way of having another look at what we're doing and another way to make sure we're doing it the way they want, which is we have to file, the town has to file a notice of project change showing what you intend to do in Boynes Pond. Now, obviously, we all know what we intend to do since the town meeting voted for it 2 years ago, and the consultants have been here going in great detail as to what we're doing about the inlet opening. But we had a meeting with the DEP and the MEPA people last week to show them what Falmouth intends to do in Boynes Pond and why. And it was a fairly lengthy presentation. It took over half an hour. I think by the end, they understood what we're doing, and they were pretty supportive of what we're doing, and we're going to work in the next 3 weeks to get, 4 weeks, I guess, to get the notice of project change drafted and before this committee and in front of the selectmen and up to the state agencies by February. So it's an ambitious timetable because it's an enormous amount of work like everything else in this world. But we got enough good feedback to think that we're going to be okay, but we have to do it. So that didn't require a vote or anything, but people ought to know that it's moving.
Could I
Sure.
just add to that? If you remember the MEPA certificate that approved the Little Pond plan and the rest of the reports that we had filed, they said any time that we moved ahead on 3 pilot projects, and they specifically named them, we had to use this legal vehicle called the Notice of Project Change, and Bourne's Pond was one of those. So this document is, by and large, about the project of Bourne's Pond, but it's set within the context of the entire planning area that we're responsible for, which is all of the southern coast peninsulas, all the way to Wakwait. And at the end of December 2019, we have to give them a plan for each of those other estuaries. So this document will be really in two parts. The inlet widening and all of the eelgrass and tidal flow and all of the aspects to that, and then a report on where we are with all of the other things that we've been looking at, the non-traditional alternatives. And we are required also to include information on sewering the Bourne's Pond watershed as another alternative. And that information had already been developed. If you go way back to the original plan, the $600 million plan that Matt, you and I stood up and said, this won't
600
work.
plus, it was 680 million.
But we do have that data, and so Sia and I are pulling that information together. And I think we will need a special meeting in January. I will try and have this report so that you all have a week to review it, but then I think we'll need a special meeting to go over and through it before we send it to the selectmen.
Okay, any other reports of members or staff? Okay, tomorrow, Friday, all these students that we've been talking about at the MBL will be putting on the results of their projects. This was sent around to all the members. If any of you have the time to go, I think it'll be interesting. They all have to do it in 10 minutes apiece. But they will be addressing a lot of the things that we're interested in. Vote on minutes of prior meetings.
Eric,
Yep.
can I just say one thing about that? If you're thinking of going to that, I strongly suggest you read the list of topics ahead of time. You may discover that there's some subset of it that you want to go to.
Right.
And another subset that you don't want to sit through.
Right. And we could offer a small incentive, which is it's free parking in Woods Hall for 2 hours at a parking meter that has a bag on it. So that takes one less hassle out of going to Woods Hall to do this.
Right. I don't think they're on MBL Street, though. I think they're just.
Well, you might have to walk.
If you can find one.
But you save 25 cents every 15 minutes.
People are extending that 2-hour liberty a little bit.
Good,
really?
good.
The police should be, I think that they're monitoring. But
Yeah. All right, minutes of prior meetings were sent around October 29th and December 3rd.
I'll move the minutes of October 29th and December 3rd.
Second.
Moved and seconded. Any additions or corrections or comments on any of them?
There's one typo. I'll point it out to see.
All right. Been made and seconded. Any discussion? All in favor?
Aye.
Opposed? The ayes have it. Matt?
Move adjourned.
Moved and seconded. All in favor?
Don't we have another set of minutes?
We did two of them at once.
We did two of them.
So we're-
Yeah, we did. That was very efficient.